yes, I'm going to break the problem so that on each core, I want to queue up 512 threads. Okay? Roughly speaking what it's saying. And then I'm going to choose enough core tasks or thread blocks so that I'm going to have one thread per entry in this array. So if I took what did I say? I wish I'd chosen an easy number. But if you take 3,789 divided by 512 and round up, that's how many blocks of threads I'm going to request. So I'm going to have enough threads that I can set one entry in. Each thread can set one entry in that array. Does that make sense? Yeah? It's just a block partitioning of a loop. And we'll see what I mean by that in a moment. OK, so to reiterate, we use cudaMalloc to allocate space on the device. We're going to specify how many threads we want. Yes?
Can you detach the thread that runs on the GPU so that you can do other stuff on the CPU and then get notified when the GPU is done?
That's a fantastic question. Did I already answer that question? Yes. What did I say previously? It's asynchronous. It's already detached. It's a thread. We're requesting that kernel gets launched, and it returns without guaranteeing the kernel has finished.
The question to that example, how does the main code know that the kernel is done when you copy the answer back?
Because the one thing I didn't tell you is that the CUDA copy is blocking. We're actually queuing up a memory copy request. We're adding that after the kernel, so the kernel has to complete before that copy will start. Yep. Does that make sense? Yep. But I try not to throw all the details in at the same time, but it's very astutely observed. Does that make sense to people? Basically, there's a queue on the device, and in this case, we're using a default queue, and we've queued in that kernel operation, and after that, we've queued in that copy operation. It's possible to overlap those things, but let's not get ahead of ourselves. OK, so